Okay, so that's going to be pretty freaking fun to ride. It's episode 2 now. I know it's been a little while, but I wanted to make sure we had something really decent to report. So, as you know, we're building a Supermoto. It's going to be hopefully around 50 kilowatts. One thing we've actually worked out is that including the chain reduction with the new sprockets we had made, it's looking like it's going to be above 700 newton meters of torque as well. So it's going to be pretty freaking amazing. What I'm going to do today is just quickly run you through everything I've done on the bike, specifically the motor mount here. The main things that we've done so far is we've finally got this engine in here and mounted up. This is marine aluminium, 6mm plate. It's mounted on all the original factory locations, so we don't have any troubles engineering. It's actually all passed, all signed off because we're road registering it. The chain line's straight. We've had our sprockets machined up here to fit a bigger chain. This is a 520 chain. It's got 8,500 pound tensile strength. We still got to do quite a lot on it, but something you might notice is this absolutely massive sprocket. We had this made up from Rebel Gears over in the States. There's the stock one for reference too, by the way. Just a little bit of a difference in gearing. That's because our motor here is spinning to 7,500, 8,000 RPM, and we've got no gears. There is a few different options of sprocket that we had made, so we can change gears for different tracks and different situations. Still have to do the shock. We're rebuilding this shock over the next week or so. Just going to do all the seals and get it back to how it should be. I haven't polished the frame or sorted any of that out yet, but we have actually done the triple clamps up here, so these are nice and shiny. This is what the rest of the frame should look like. We stripped the forks down, rebuilt all the seals, so they're good as new. We've got 17-inch Supermoto wheels now. We've got a 320mm rotor. We've kept the same caliper, the stock caliper for the moment, with a just a bracket to match the 320mm rotor. We've just powder coated this, same way we did the rear disc. We're going to do eventually everything. So the pegs are going to get done. The stand's got to be chopped down to match the 17-inch wheels. This is going to be polished on the rear shock. We've still got to make up a new chain guide. This is obviously has to move because the stock one was back here. We're going to slide up there and machine up a new chain guide that actually suits and keeps that chain in line while we are riding. Okay, so that's pretty much everything that's happened on the bike since last time. I'll give you a better look at this mount. You can see it's using all the stock locations and it's basically bulletproof. Thanks to Matt for that one. Really happy with that. We've gone to a bigger chain and everything on the bike is coming along well. I'll head over here now and I'll run through all the new stuff that we're about to put on the bike and the next couple of steps up here on our Gone in 60 Seconds whiteboard. Here's the stuff that we've got and we've still got to put on the bike. We're going to try and do a bench test soon with the controller and the motor and these new batteries hooked up, and we'll see how it goes. So like I said before, those phase wires have got to be replaced with much thicker double insulated NCOP 14 compliant cabling. That's what this is here. We've got BMS wires that are going to link all of our individual cells up to the BMS here on the battery, so we can monitor the performance of the cells and just make sure everything's behaving like it should. These are the massive lugs that we are going to be using because we're pulling not only 600 amps from the battery, but we are actually pushing 800 amps from the controller into the phase wires. So there'll be 800 amps split over 3 of these, and then there'll be 600 amps going from the batteries into the controller. This is the controller that we're using. It's a Mobipus 72600. So it's rated for 72 volts, but 90 volt maximum. We're running it at 90 volts and 600 amps. So it's pulling 600 amps from our batteries here. These are the cooling lines that I've started to match up. I've got to route them through the bike, And instead of using a reservoir, we're going to have a T-piece and then a filler come up, and then the actual old fuel tank is going to be the coolant filler. The controller will have an interface, or does have an interface, which runs on a Windows tablet that's mounted on the handlebars. We're going to do it a lot neater than this, but here's our interface. We've got a speedo, battery voltage, battery amps, phase amps going to the motor, and our obviously a digital speed. If we exit this, the controller itself is actually the motor programming software. So we can either have a graph setting, a data recorder. We've got all the regular stuff, and then we've got full control over our controller settings here. That's actually adjustable on the fly or on the side of the track via Wi-Fi. So I'm pretty excited to get this going. We've got a Wi-Fi module here, which is actually installed on the bike via a RS485 connector, and then the tablet is connected via Wi-Fi to the rest of the system. So we don't have any wires running up to the dash. This is just going to be mounted down on the bike. We're using a Domino throttle, which is probably the best electric bike throttle I've ever used. The options are either to use a Domino throttle like this, which is a potentiometer throttle, or to use Hall sensor throttle, but I've always had good experience with these ones, so we're going to use Domino throttle with the M-Force controller. We might need a resistor in the line somewhere, just to make sure they work with each other. Ignition barrel. It looks pretty much like a standard ignition barrel. The only thing is we've got a 2-stage now instead of the stock 1-stage. So when we twist it onto stage 1, that'll turn on the 12-volt DC-DC converter, and it will also activate and close the circuit for the pre-charge resistors. And then the second step will activate the main contactor, which is actually just down here. The second stage will activate the main contactor, which physically connects the controller via the main cables to the batteries. So we've got a two-stage there for the ignition. The M-Force controller actually has a safety brake cutout, so even once everything's live, if the kickstand's down, then you won't get any throttle, so there's safety there. And if you haven't activated the bike by tapping the brakes, then you actually won't get you won't get traction motor power there. So it's a little bit of a safety feature, because when the bike's running, there's no noise. You can walk up, twist the throttle, and cause a whole bunch of damage. Here's the harness for the 72600. It's got sine cosine motor connector, the RS485 communication connector, and then this is the connection for the harness, which will have your throttle, your safety, your brake, and all that sort of stuff. So it's all relatively straightforward, but it's going to be the next step in wiring. This battery here is a 90 volt 30 amp hour battery capable of 40C. So 40 times 30, we're looking at actually 1200 amps peak output from this battery. We're not pulling anywhere near that. We're pulling 600 amps maximum at the moment. I'll get into that a little bit later, but the controller is actually unlockable to pull more than 600 amps. We can probably go to 700, which is actually 63 kilowatts. But for simplicity's sake, we're going to say 50 kilowatts and 600 amps from these amazing batteries. They were made by Chris Jones from Voltron, who's absolutely annihilated his race series this year. You should check it out. Go on YouTube, have a look at the Voltron bike. It's running, I think, about 230 horsepower. So he really is the man when it comes to batteries. I've got to harness up a BMS harness, which will link these two auxiliary batteries to the main battery, the BMS down here. So that's on the list of things to do. Our cooling system is here. We've got a 37 watt adjustable flow pump. We've got two waterproof brushless fans. They'll be running on just a 12 volt DC-DC converter as part of the main circuit. That'll be running, won't be running through the reservoir. I got one just in case, but it looks like I'm going to use a T-line instead. This radiator is going to be mounted in front of the batteries, but not on the stock location. The batteries will actually be on the stock location on the bike, and this will be hidden slightly lower. Over here, we pulled out the previous wiring harness. Instead of trying to cobble one up from the stock harness again, we're going to start and do an entire 12 volt system in one go using this Ultima Plus loom. So there's going to be a little wiring here to go, but it comes with everything all built into the one system. It's got the relays, it's got the circuit breakers. Instead of all the ugly stuff that you need to put in a stock bike's fuse box or fuse/relay box, everything's self-contained in here. And even though it looks like a lot of work at the moment, it's actually going to be a lot simpler than trying to use the stock bike loom and then cut out all the engine stuff that we don't need anymore because we're running an electric motor. Comes with all the connectors and everything we need to really do quite a good job. This will be getting its power not from a 12 volt battery like would happen on a regular motorbike, but the power for this and all the 12 volt system is coming from this 20 amp DC-DC converter. This is going to step our voltage down from 90 volts to 12 volts. It's got a common ground, and we've got one input which takes out 90 volts, and then it puts out a solid 20 amp 12 volt output. Something that's not here is from the 12 volt system, I'm actually stepping down to charge the dash because that needs a 5 volt system. So I've got a 90 volt system to a 12 volt system, then that's actually stepping down again to 5 volts so we can power the dash independently. So that'll be pretty interesting to wire up. But the main battery, the traction battery here, will actually be providing most of the power to the rest of the system. We've got the brake levers here, front and rear. Basically a stunt brake lever setup. I'll be running new brake lines and new brake switches to have both the front and rear mechanical brakes or hydraulic brakes, but the physical brakes that are actually connected to the discs compared to the regen, which I'll explain later, are actually controlled now by your brake levers. The guys at Big Knob Sliders sent us this. It's a full motard kit for the CRF, which I'm pretty excited to put on. Obviously they know that we like yellow, so we've got our front sliders, our rear sliders, our peg sliders, and our bar ends. That's really going to help get everything ready and stop us doing, well, limit the damage that we do if/when we come off. So really stoked that these guys sent them out. They were highly recommended. We've got indicators because obviously we are doing everything road legal. We've got indicators, headlights, brake lights, all the road legal stuff, but I decided to get the click and ride ones so we can actually disconnect them when we're on the track. We don't have to worry about breaking them off in a crash again if/when we crash. So I'm pretty excited about that. All of this stuff and the bars and the fairings and seat cover and all that sort of stuff, we've reupholstered the stock seat. This is actually the stock seat redone in black, so we're trying to reuse everything we can. All of this stuff comes from mxstore.com.au. They've been super helpful with the build, actually. Almost everything standard motorbike wise, anything you need for motocross or supermoto, I've got from mxstore.com.au. So they've been really cool. Thanks, guys. We've got Pro Taper bars here. I went with a 7/8, and I might actually run it without the cross pad, only because I've got a few gauges that I've got to put on there. So I'll deal with that when I get to it, but I wanted to make sure the bars have got a good feel for the track and for the road. Bolt kit. We are replacing every single bolt on the bike as we go. So this has been super handy, especially because when I pulled it apart, as you saw in the last video, I was not particularly gentle. Here, this rear fender is actually notched out. I'll show you why I've done that later, but it's a stock rear fender, a stock CRF R rear fender, not a CRF X, and I've just molded up this out of ABS plastic, and then I've plastic welded it or plastic glued it on there using this concoction here. It's actually shaved up chips from the original piece of plastic, and then it's melted by putting it in a cup full of MEK, and it turns into like a sloppy goo. And as you put the goo where you need it to be and you push the two pieces of plastic together, the MEK evaporates, leaving just pure plastic behind, and it chemically bonds the plastics back together as if they were never apart. I mean, you can obviously see the line there, but physically that's bulletproof. It's as good as a stock one. But I'll explain why I needed that later when I get to installing the controller in the bike. The next step is to see if we can get the motor turning. We've got to connect the controller up, the Wi-Fi receiver, the throttle, and see if we can get some revs and tune the motor up and see how it goes. The negative here is shared with the negative on the 12 volt system. So we'll connect the positive of the 12 volt system up here to the positive terminal of our external battery. On the finished bike, we'll be using a 12 volt converter. Things done. Let's see if we can log into the Wi-Fi over here. Okay, we're connected to the controller. We're showing 81.9 volts. That's because we're running off a different power pack here. What we want to do here is see if there's any warnings. So it's waiting for an active brake signal. We take this and we short out the to brake, or the brake to power, which will activate our throttle. Okay, I think we are live now. Let's bring the dashboard up and see if we can spin the motor. We have ignition. There we go. So we've still got to do a little bit of tuning, because we've got to set the gear ratio, the rear wheel size, the amount of flux weakening, which basically is a way that we can simulate a lower back EMF. We can run a higher RPM than we normally could with this voltage. That's something that's really good about this controller. So we can set our desired top speed. So I'm going to do that now, and I'll see if we can get a little bit higher RPM. Enabled flux weakening, we should get a slightly higher top speed now. Alright, let's do a little bit of a run here. I've got to do it slowly, otherwise the torque makes the bike a bit unstable. Whoa. Okay, so that's going to be pretty freaking fun to ride. That was about 60% of top speed, top throttle there. Cool. Alright, let's find a home for the controller. Here's the best place to put it. It'll give us a better center of gravity because we're going to have the batteries up here on the radiator mounts and one down the middle. I've just mocked it up with some little L brackets here, but we're going to weld those together with like a H plate here. And on top of that plate there will be some heat sinking. I might even make it take up the whole thing. I'm not 100% sure yet. But this will let us put the controller in and have it mounted there just under the seat. So I think that's the way to go. Now I'm going to mock it up and put the rest of the fairings on just so I can make sure the battery's going to clear under the fuel tank and start doing the routing for the 12-volt system. So. Up under here is where the batteries are going to go. It's actually going to be a major step, but we've got to fabricate up some aluminium battery boxes. They're going to be mounted on the radiator support and they'll be connected there like that. So that's going to be one of the next episodes. That's the next major step that we've got to complete. This is where we're at with the bike at the moment. We know the motor runs, we've got the chain on, the new sprocket's done, the chain's cut to length. Next time is going to be the battery box, and this mounted in there. This is going to be our headlights, indicators, horn, all the legal stuff that we've got to do, as well as our 12-volt supply for the contactor and the electrical system for the motor. We're going to fabricate up another piece of plastic here where the airbox was, and it's coming along. At some point I'm going to take everything off and powder coat all the extra stuff as well, like we've done here with the brakes. Well, I guess that's that for this episode. I'm going to get to work getting everything else sorted, and next episode we'll do a run with the chain on and hopefully do our handlebar mount and all that sort of stuff. This is our dash. Eventually our dash is going to be mounted up there behind the handlebars. Sweet. I'll try and do the next one a lot sooner, probably in about a fortnight. So check back on Sunday next week or the week after. Thanks, guys.